I would now like to invite Dr. Danny Bickson from GraphLab, who will tell us quite a bit about how to use the GraphLab framework for big data analysis.
So thanks for Lior and Bracha for inviting me, and would love to tell you a little bit about GraphLab. So GraphLab started 5 years ago. It's an academic project out of Carnegie Mellon University, and it's also an open source project. So I do hope that many of you will be interested in trying it out. And about a year ago, we formed a company which supports the open source project in Seattle. So I'll tell you a little about what we learned during the creating this project and what's our future plans. So we started GraphLab working mainly on graphs, as you may imagine. And graphs are basically, we treat everything as a graph. So a graph could be a Twitter network, a graph could be whatever interaction, phone call network, interaction between people. It could be presence of people in images. It could be a G network, or some relations between blog posts or Wikipedia entries and so on. And it could be many other things. So basically, we treat almost any big source of data as a graph. And in machine learning, graphs are a very fundamental building block because they can actually explain some kind of the interactions that are happening in the data, can try to maybe understand the data structure, what is more influential, what is less influential, do some reasoning, and also model dependencies in any kind of data set. So I'll give maybe a couple of examples about things we can do with graphs with machine learning, but of course there is an infinite number of examples, so we'll probably get the idea quite quickly. So one example I give is more of some kind of sentiment analysis, trying to identify which users like which kind of topics, news topics. So basically we have two types of users. One of them is red and the other is blue. They are writing some blog posts, and there is some network of followers who read this information. And the problem is that most people basically don't write anything, so we don't know exactly what they like. But we do have information about some kind of social networks, who is following who. And then we can learn by this following relation actually the kind of preferences of the users, even if they never wrote anything to anyone. So that's one example, and in the machine learning terminology, this algorithm is sometimes called label propagation and also used for recommending products. Another example, in a social network, there is an algorithm which is called triangle counting. And this is a very quick example. We have a very simple graph here. And basically, we start from the blue node, and we want to see on how many triangles it participates with. And basically, the triangle is if we have a link between two friends are also friends, then it means we have some kind of a small community. And in this example, we see that there are a few triangles around the blue node. So why it's useful? It's useful, for example, for advertising. So if we publish to someone who's very well connected, and he can tell about it to his friends, and the friends will discuss it among themselves, and maybe they will buy some kind of a product. So that's another example for a graph algorithm for social networks. The last example is a graph for recommendations, which is one of the area domains where GraphLab is most active, actually. And so we have a bipartite graph. We have a set of users. We have a set of items they bought. There are some edges which signify what they like. And each edge has a certain rating to this edge. And basically, we can learn from the graph and use it to recommend new products. And the way it's done, most of the algorithm build a model. They can follow some of the information back and forth this bipartite graph, and actually recommend some new sets of products. So that's another example for a useful graph algorithms people often use. We like to show this example. Basically, in a few years ago, there was a big company which is represented here now, formerly as the Alta Vista, and basically a new company came with a very good graph algorithm and also a system to support it, and then improved significantly the search results using this automated algorithm. And previously it was more of a hand-labeled results, and once they made it more scalable and more automated, they were very successful. And the graph algorithm they used is PageRank. I guess most of you know about it, which is another algorithm which ranks nodes in a network. So basically, I showed a very small set of examples. There are many more, and this list actually is some of the algorithms that have been implemented in GraphLab so far, and there are many others. So it's a growing set of algorithms, but you can see that many algorithms can be represented as graph, basically. It's not a limitation of the system. So I'll tell you a little about the open source project GraphLab, which, as I said, started 5 years ago. And in it, we actually have an engine that does what we call graph processing. And basically, we treat the data for the problem as a graph. We have some state of what's the current state of the problem, and we store some information in the nodes and on the edges. So for example, in the PageRank algorithm, the information could be the relative rank of this node and some weight on the edges. And we, furthermore, besides of the state, we actually do some kind of computation on top of this graph. And this example shows that we have this blue node is running some kind of computation which is dependent by its neighborhood. So basically, we implement graph algorithms which have some local computation in their neighborhood, and they are iterative because they do a lot of passes over the data. This kind of framework we call graph parallel, and the main difference then versus data parallel, which is implemented in Hadoop or MapReduce, is actually in data parallel we need to split the problem, the big problem we want to solve, into a lot of small and disjoint parts, do some kind of computation, and then do some kind of aggregation to continue to the next step. In GraphLab, we actually have the dependency graph directly, and the graph nodes can communicate between each other directly instead of doing aggregation and writing and reading from disk. So basically, we are way faster for this kind of machine learning algorithms. And I'll show just a nutshell of a few performance results. So in GraphLab, as I said, we have the graph which represents the problem, and we have the computation, which are what we run on this graph in order to compute some kind of machine learning algorithm. Now we go to the intuition. Actually, that's a quite recent result. That not everything is a graph, and I'll give one example of why sometimes the tables are actually very useful for storing information. So basically, let's say we imagine we want to run a PageRank algorithm for rating some Wikipedia pages to see which Wikipedia article is more important or influential. So basically, the kind of problem we are often encounter is actually we start with some raw data, which is the raw Wikipedia, and then we have we throw out some of the images or whatever data we don't need, and we go to some kind of a table which has the title of the article and some information within it. And then we can, there are a few ways we construct links between it. For example, the links could be papers, articles that point one to each other. And then we can run a PageRank algorithm and eventually find out who are the top 20 interesting Wikipedia pages. So in this kind of transition, we actually shifted between a table form and a graph form. And this kind of thing happens in a lot of kind of practical problem. And also the law problem is another example where we actually, instead of building a hyperlinks graph between Wikipedia pages, we can actually find what's called the term occurrences matrix, which actually words that are in a certain page, and then we can find the topics of those Wikipedia pages, and then there is a different algorithm which is called LDA, which finds those topics. So basically, we are transitioning a lot between tables and graphs. And previously, the GraphLab open source project was focused only on graphs, but now we actually start to support also tabular formats. And this is what this is the new stuff we're working on, which we call GraphLab Create, where we have a building block which actually combines both tabular formats and graphs in order to have fast processing, and you can switch between the representation using the same kind of data structures. So I'll tell you in a little more about that, but first I will start with some performance results. So basically, the open source is known not for its ease of use. Basically, it's not easy to use it. We're now working on actually on that. But it's known more for performance, because as an academic project, we were more interested in saying we run 50 times or 100 times faster than the previous system and write papers about it. But it didn't interest us so much for people to use it to become very usable for a wide audience. So I'll give, I think, a couple of examples about GraphLab performance. So these slides, actually, I'm not aware of all the details. I know it's a LiveJournal network, which is some form of it's a web social web graph, which with around 60 million nodes. But what's nice about this slide is actually that I didn't write it. We stole it from a presentation by Spark, which is another system. And what's nice is that they actually say that GraphLab is faster 60 times more than Hadoop, which is Mahout, which is another machine learning framework, and we are faster about 60 times more than Spark. But basically, if we would run those same kind of experiments, we are getting even some better results. But I wanted to show it as our competitors basically claim. Another example of maybe reusability is actually another system for solving topic modeling problem, which was done by Alex Mola when he was in Yahoo. And there they have a system. They built a special system. They worked about it for a year and wrote a paper about it, which goes over Wikipedia and does computation of topic assignments to Wikipedia pages. And they measure the system in terms of performance, how many tokens they can go over in a cluster in a second. So basically, they have very good performance. They can go over almost 150 million tokens in a second in a cluster, and the algorithm progress by going over more and more tokens and assigning topics to documents. What's nice about GraphLab, we have slightly lower performance, so we are less good in terms of performance, but we didn't write a special system for this task. We just used GraphLab, and actually we had one of our students write one GraphLab application, which is a couple of hundred lines of code, which does exactly that, but it was a very small effort in terms of building a special customized system. And the idea is that GraphLab provides an abstraction. It provides a computational API for implementing graph algorithms, so you don't need to write anything related to communication or load balancing or locking, and you can focus more on the algorithm itself. Last performance example I will show, this is another work by Yahoo again, which was published 3 years ago in LiveJournal conference, where they actually performed this triangle counting task I mentioned. So it's an exact algorithm. They have this huge Yahoo cluster with more than 1,600 machines. And basically, they run the triangle counting and get a number, how many triangles are in the network. So we actually use the same data set, the same algorithm. We get the same exact results, but actually we do it way more efficiently. And it's not the exact same hardware, but still we are way orders of magnitude faster. And the reason is that GraphLab is a framework which is much more appropriate for this kind of iterative computations on graphs. We also have a growing user community and contributors. So in this example, I show our first conference in 2012. We had around 300 people. It's very dark to see it, but you should believe me. And on the right side, we have last year we had almost 600 people, and actually this year we are again organizing a conference, annual GraphLab conference, and we hope to get to 900 people. So we have a growing user community. And the community is not just attending conferences, we also have growing code contributions from GraphLab from our community. So I'll show a very brief example. So we have one contribution from Kobo, which is the Amazon Kindle competitor, which does something related to text mining. We have Mikhail Lesnik, which is a former Israeli, which is now in King, the Candy Crush game. So we found out they are actually using GraphLab to compute moves and recommend moves to users, which is a nice application. We have DARPA projects who contributed code to GraphLab in all kinds of application, also in computational biology, finding new application to medicines. And we even have a vision computer library for vision, which is Cloud CV, which is implemented on top of GraphLab. So that was a snapshot of the open source, and as I told you, we are now actually a company, so we want to support the open source, but we want to actually improve upon it and make it way more usable. So we thought a little what would be the best things to actually have to do next. And we got to the conclusion is that actually implementing machine learning algorithms and using them is a very difficult task, and there are a lot of reasons, but I'll outline some of them. So basically, we don't have a lot of people who knows applied machine learning, large-scale machine learning. So you need to have some kind of PhD in a related field to become useful. Also, it takes some time to, even if you have a very nice, you have invented a very nice algorithm, you have it on MATLAB, it works very nice on 10,000 graph nodes, but now you want to scale it to 100 million, and then you need to re-implement everything on top of Hadoop or some other infrastructure, and that takes a lot of time. So 6 months, when talking to companies, 6 months is like the fastest ever, but many companies could take a year or two just to implement a nice idea into a production environment. And also, in many cases, the machine learning papers are full of math. They are not so clear and not so reasonable to know if they actually this method can be used or not used, or maybe they just published to get the publication in a conference or something. So it's very hard to distinguish. So we are trying to actually make all this process easier and make our GraphLab packages way more accessible. So how do we do it? We have 3 steps, 3 ideas on how to do it. So the first one is actually regarding to education, is actually to help learn and teach people to use machine learning. And the way we do it, I will explain in a second. So we are using what we call a GraphLab notebook, which I'll show an example. The second thing we like to do is actually make installation and deployment much easier. So the open source is you need to have a couple of hours at least if you are a good system admin. But now we are actually switching to a Python package which wraps GraphLab. So basically the installation is a one-line command because it's now it's a standard Python package. And the third component is actually making deployment way more easier by actually allowing you to work on your own laptop, fine-tune your algorithm on small data, but once you want to get to a much bigger data set, then actually switch to a cluster and use the same Python code, you just connect to a different GraphLab instance. So that's regarding the deployment. So I'll give one example of GraphLab Notebook, but I encourage everyone to surf to our website, which is graphlab.com. Everything is for free, and you can play with it. We have a lot of notebooks which illustrate all kinds of machine learning recipes. So that's one of the most popular examples we have, which is a Kevin Bacon game, which is to try and find out who are the most influential actors in a movie graph. So the idea about notebooks is you have small snapshots of code. You can just run using play, run this code, and then you can see the results, what's happening, and then it teaches you, and then you can change the code interactively and point to your data and play with it. So that's the notebook. Regarding the prototyping, we have, as I mentioned, the GraphLab Create, which is a Python package. And the bottom side, we can see a very small example on how to actually compute a recommender system, build a recommender system out of raw data. So it contains 6 lines of code. And if you like to do the same thing in GraphLab or Mahout or Hadoop or Spark, you will need way more effort, basically. So here we wrap everything to make it much more easier and accessible. And this is the installation I talked about. And we are starting to create a lot of toolkits from different aspects of machine learning that implements different algorithms. So as I said, our most popular so far is everything related to collaborative filtering, but we have also toolkits in computer vision, graph analytics, graphical models, and so on. And we are adding those to the Python as well. So the idea is that we want to enjoy the speed of GraphLab, but we want to simplify everything. So basically, we want to have a large menu of different algorithms to play with, a large menu of recipes to try out. And then we believe it will significantly simplify all the process of trying out machine learning methods in practice. And this is the last example where we show how to deploy the same. The bottom box shows that you can actually launch a GraphLab instance on an EC2 cluster. You can select how many machines you like and run the same kind of algorithm that you run locally on your laptop, also on remotely on a cluster without changing the code. So I won't have much time, or else I would give some nice demos, but I encourage everyone to go to our website and download it online and start playing with it. Installation should be quite simple. And this is the way how we propose to address the problems I mentioned by education, simplification of the process, and providing a lot of toolkits. And this is my last slide. So thanks for your attention, and be happy to connect with anyone later, with anyone who has questions or want to try out GraphLab.
It was quite fascinating. So you said a lot about the what, but not really about the how. Can you share a little bit of your wisdom with us and compare, for instance, GraphLab underlying technologies, for instance, with Pregel, which was one of the first efforts at Google to start looking at these problems?
Yeah, so that's a great question. So basically, Pregel is a project from Google who started this kind of graph analytics domain, and it's what's called bulk synchronous parallel, which means that all nodes run iterations one after each other. Basically, GraphLab does bulk synchronous parallel. The main difference is that Pregel is not open sourced. So there are other projects which are like Giraffe and so on, which are open source. But now we are actually taking, so there are technical differences from the fact that we support also asynchronous iterations. So basically, algorithms like BFS, for example, which are hard to program for Pregel because you want to have some kind of dynamic flow on the graph, are much easier to, are supported in GraphLab better. But basically, now we're taking maybe 2 or 3 levels higher. So basically, imagine you have Pregel and you have Spark and you have a lot of systems, but the thing is that they are not so usable because you have to really be an expert to understand. And initially, we were targeting the real expert audience. But now let's assume you're like a smart programmer or some engineering company and you don't know anything about machine learning, but still you want to enjoy properties of machine learning. So this is the main thing we actually tackle now. And so regarding basically GraphLab, as far as I know, is the most popular system in terms of open source, which is currently used. So Pregel is, as I said, not open source. Giraffe has very minor market share in terms of, it's not a market, but it's open source market. So GraphLab is way more popular, but still we would like to, but still the users are highly experts, and we want to go one step ahead. So actually making it way more accessible to a much larger audience.
Hi, small question. How actually you are scaling? I mean, in NoSQL database you can scale by row. Yeah, you can just copy row. And SQL databases you can scale by make let's say sharding. Okay, in Graph actually how you are scaling.
Okay, so basically we have two versions of GraphLab. One is multi-core, which may scale maybe by the number of cores, but I guess you are talking about the distributed version of GraphLab that we have. And there we split the graph, these joint sets of the graph into machines. So basically you can add more and more edges. So we split the edges. That's in initial GraphLab version. Later we find out that a lot of parallel graphs, you have one node which can have 500 million edges because all web pages link to Google search or something like that. So that's very hard to scale because if you split this node to a machine, then all the edges will have to be stored in that machine. And then we actually changed our partitioning strategy and worked by splitting edges. So we have some copies of nodes. So I don't have time to enter all the technical details, but I'm happy to share some papers about it. And so far we have tried GraphLab and up to clusters of I think 256 machines, and we are scaling in performance.
Okay, thank you very much. This was great.